All right, we are live again. Hope everybody went and got their stuff from the school. I know I'm going to be missing a few people from this stream because they are still in the process of getting their stuff from the school. And that's fine. This is going to be a shorter one. It's over ratios and proportions. This uses the math book that you got over the summer last year. Yeah, I mean, but it's basic stuff. Ratios and proportions is. Uh, you got. Yeah, you can go anywhere and find information about ratios and proportions. But yeah, let's get to answering our questions. All right. So I decided to put a little question in here to remind you, hey, go to the school, because I know a lot of people don't watch the live streams, so I'm not interacting with them. So this is a way for those of them that are only doing the Socratives for me to interact with them. What was the correct way to express a ratio of 60 feet to 30 inches? 24 to 1. So this one's kind of a trick question. Because you got to get it all into inches. So how many, I mean, you could get it both into feet. So it'd be like 60 to 2.5. And then you could solve that one. But you got to take this 60 feet and turn it into 720 inches. And then you would divide that by 30 to get the, so that turns the 30 into 1. Technically, you're dividing both sides by 30. So 24 to 1. And the order that you write these things down is very important. So this was 60 feet to 30 inches. So that's 720 inches to 30 inches, which comes down to 24 inches because you divide both sides by 30 to 1 inch. And really, this last one doesn't really need a unit because it would also be 24 feet to 1 foot. Yes. That's why you wouldn't go 1 to 24. In a series circuit, voltage drop across a resistor is proportional to its resistance. If resistance of R1 is 200 ohms and voltage across it is 2 volts, what is the voltage across R2 if its resistance is 80 ohms? So, R1 is 200 ohms and 2 volts. R2 is 800 ohms. Oh, no. So we have a ratio of 200 to 2, and that will be equal to 800 to x. You're going to cross multiply, so we have set up the, let me see exactly how they put it. We set up the proportion. Now we are going to substitute the values, or really setting up the proportion would be R1 over E1 is equal to R2 over E2. Then we replace all those values, R1, E1, R2, E2, and then solve by cross multiplication. So 200x is equal to 2 times 800, that's 1600. Now we will divide both sides by 200. This cancels, this cancels. 1600 by 200, that would be x equals 8 volts. Another corner that you can cut is you can, before you let's see, there's some, you can reduce fractions and stuff, so you could have made that 100 over 1, and then whenever you multiply, it's a little bit simpler. A blank is the statement of relation of one value. So this is a proportion. Ratio? You're right. It's a ratio. My bad. So this is a little joke that I have during math class. He can steal 250 cupcakes in 4 hours. How many hours would it take him to steal 12,500 cupcakes? In the real world, you would run into supply issues at this scale. Where is he going to get 12,500 cupcakes? So 250 and 4, 2,500 and blank. So we'll call this C1, and T1 is equal to C2 and T2. That's cupcakes 1 and cupcake time 1. And our question was 250 and 4. Uh, 12,500 over time 2. So can we, I don't know, can we reduce anything? I don't like it, it's not clean. Alright, let's cross multiply, so that gives us 250 times T2 is equal to, oh, I don't have a calculator up right now. I need to program a button so I can just hit a button and get my calculator. $50,000. And now we can divide that by 250. T2 equals, divided by 250, 200. T2 is 200 hours. Alright, and this works the same if it is transformers, which is a little bit more on the nose for what we'll be doing. Yes, whenever they're directly proportional, you set it up just the same way. So, in a transformer, let's just select. Do the select and delete method. Alright. So this was our cupcakes in time. So in a transformer, you're just going to take um, so your voltage on the primary winding. So E1 and T1, where T is turns. That's how many wraps of wire are around the core. E is voltage, we've been doing that. Then you would have E2 and T2. This will be your primary. Now, primary and secondary are just different sides of the triangle. Not triangle, transformer. And this is nothing more than a regular ratio. You don't do anything special. And you would just fill in your numbers as appropriate. I was just showing you how to set that up. Some people have trouble inferring from one thing to another. Well, that was cupcakes, and this is a transformer. It's clearly not the same. These is not a step in solving proportions, and that is invert the proportion. That's not a step that is used to solve a proportion. Okay, and then finally, this was a directly proportional. Everything we've talked about so far is directly proportional. If it is inversely proportional, what you would do, so this is direct. If you're trying to read things that are inversely proportional, which current is inversely proportional in a transformer, but don't worry about that. Just know that directly proportional is set up like this. Inversely proportional, you're going to have I1. So your primary sets up the same way. And then this is the only difference between the two. On your secondary, you flip this. So you'll have T2 over I2. It's erased. Waka 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 waka. Okay. That's erased. So you have T2 over I2 instead of matching. Instead of it being the same across both sides, it's inverted. It's inversely proportional. And that's how you do it. It's very simple. Feel free to look up inverse proportions for more information. Alright. And that is the end. Now let's look at the results. Alright. Let's end the activity. And let's launch lesson 4. Lesson 4 is a go. Lesson 4 is voltage in parallel. Thing to know about voltage in parallel is voltage stays the same at all points. Or the whole voltage is dropped down each leg in parallel. So just like in your house, you got 120 volts starting out, you have 120 volts on each load. That's the big deal about voltage in parallel. Alright, I'm going to end this here. We'll see you guys in about 2 hours.